Hello everybody, my name is Yasser. I help Dell Desleski for software engineering economics. So for this semester I help in case study 1 and case study 2. So in case study 1 we're still working in COCOMO model, and I created this video to just give you like introduction to let you know what's the COCOMO model is about, because the case study is requesting you to do some calculation for the COCOMO model, but I thought it's a good idea to introduce you to the model itself, so to not be confused and to try to understand the whole picture of how the model is working and how it's been developed. So for that reason, I will introduce you to this is my email address, by the way, if you need to approach me if you have any question. And let's start with to understand the different techniques of software cost estimation. So we have different techniques. We have algorithmic models, and one example of that is COCOMO model, and there is also several others. There is also expert judgment model, which is based on experience of expert, and there is estimation based on analogy, which compares the new project with several other projects have the same characteristic, like the size or any other requirement. So there is also price to win estimation, and this price to win is not a good idea because usually the company or the person who would like to win the contract will go for the lowest price just to get the deal, and it usually produces overrun in schedule and overrun in cost, so it's not a good idea to have this approach. And there is also another several other approach like top down or bottom down. So in bottom down you analyze every small file, and you calculate how many efforts required by this classes, and then you sum up all the files or classes you have, and you calculate your total effort. And the top down approach is the opposite way. So you start from the large project, and then you scale down to the lowest specifications of the software project. So our focus is in the COCOMO model, and this model it's first is developed in 1980s by Barry Boehm, and it's one of the most widely algorithmic model for effort estimation. So what it does, it predicts development effort and schedule based on the size and cost drivers, which are the metrics. So our metrics are our cost drivers are related to product, computer specifications, personal attributes, and project attributes. So for this you need to have the size, you need to estimate the size, and you need to let's give you an example. For example, you are a software company, okay, and you have your software project manager, and you have a customer want to develop a software. For example, customer from company X or company Y, he approach you and he ask you, okay, we need this software project to do this and that, and he gave you all his requirements. So you have like several meeting with this guy and with other people maybe in the same company. For example, if you developing a software project for human resource division, then you sit with the human resource guys and you ask them what they need actually for this software to do. So when you collect all the requirements and you have you need to specify or you need to think about what specification are needed for this project. So you need to rate the metrics, the cost driver metrics, and also you need to estimate the size. There is also several approaches to estimate the size, but is not our scope in this talk. But what we need actually in this simple model, we need to have size estimation, and we need to estimate the cost drivers in order to estimate the whole project. So let's go to see how specifically we can estimate those, especially the cost drivers. So it's actually the COCOMO model is two-step. So you need to have the to calculate what is called nominal effort, which is the effort by one single man in a month. So first, before starting step 1, you need to, or within step 1, you need to specify what development mode is your project going to be. So is it we have three types. We have organic, we have semi-detached, and we have embedded. So basically what is the difference between them is the organic is the small and simple software, the semi-detached is the intermediate software in terms of size and complexity, the embedded is very complex and large projects. So when we determine the type of project or the development mode of the project, then we can easily calculate after knowing the size of the project, or after we estimate the size of the project. So we need to use one of these equations. So we need just for the nominal effort. So we don't need the schedule for now, but we need to focus in these three formulas. So here we just plug in the lines of code in kilo, and we just apply this formula to get if the project is organic. If it is semi-detached, then we plug the lines of code here, and we apply the formula, and we have the results. And the same thing for the embedded project. So how to do that? We need to go to our data set. So we moved our data set to this Excel sheet, and we have actually so those our metrics. So we will start from some metrics are not really important, like for example if it is the project is designed for the ground or the flight system, what center or what year this project developed. Okay, it's good to know, but what we need is first is here actually to use our COCOMO model. We need to go to here to the mode, so we can see here our project development mode. So we can see here we have like 21 projects are embedded, and only 3 projects are organic, very small projects, and the rest are semi-detached, and those are like intermediate project or medium project. So from this information here we can calculate our nominal effort. So where our nominal effort is calculated, so here our nominal effort. So how to calculate? We come to the first cell and we apply this short algorithm here. So we plug the if statement here in Excel sheet to calculate the nominal effort for every project. So here it says if G2. What is G2? G2 is the cell number which is contain the first project. So this is our two project, the first project, and G is the column. So G2 is here. If it is let's go to our statement here. If it is equal to semi-detached, then we plug the formula here. The formula is 3 multiply AL2. What is AL2? AL2 is the lines of code. So we multiply this by the lines of code and then put to the power of 112. Okay, 112 is here because it's semi-detached. Okay, so and then we need to create another if statement. If G2 is organic, then we need to plug this one. We need to have this one, 3.2 multiplied by the lines of code to the power of 105. And the last thing, we don't need if statement because this is else, you know. So this is if, then if, then else. So this is else. So there is the last. So if this is not if the conditions here are not satisfied, then we will go for this which is the last condition, which is going to be if it is not semi-detached, it is not organic, then obviously it's going to be embedded. So for embedded, it will calculate this formula and it will. So actually this calculate our nominal effort for all projects. Okay, for this part we are done. So the next step is to calculate the multiplier. The multiplier are the cost driver metrics. So here the table from the book here, it's show you how every metric and what's the equivalent numerical to the categorical. So we have here the reliability, and we have this is the equivalent of the reliability. When it is very low, it is 0.75 and so on. So how to convert this? Also, we're going to create if statement after every metric. So we start with the reliability. We create another column here, call it reliability 2. Reliability 2, we create also another if statement. So we start if h2, this is h2. Okay, so if h2 is equal to, and remember to put the this is in quotation, so it has to be like tested as a character, you know. So if it is h2 equal to very low, then you convert it to 0.75. Then another if h2 is low, then equal to 0.88. If it is equal to nominal, then it is equal to 1. If it is high, then 1.15. Otherwise 1.4, and so on. So for everyone you need to create if statement. So remember, if a statement is not difficult to implement. You can search on YouTube how to implement if statement on Excel. So you need just to this is the format or the syntax how to do it. So you need to put off if, and then the logical test, and then comma if the result is true. So what do you want this to produce? If the result is false, then the other value is produced. So and you do the same for all the metrics. It's going to take from you a little bit of time. I mean, like maybe half an hour or less. So it's going to be okay for you guys. After you finish with all conversion here, then you need to understand how it works, you know. I know this is like what you need now for this assignment, but it's good to understand what how this is determined. You know, for example, reliability here. How to determine reliability is there is different level. There is very low and there is very high, because the person who's going to determine the reliability is the software project manager, who, after listening to the software requirements from the customers, then he need to decide, okay, this project is highly critical or very high critical or very low critical. So very high critical, that means the software has to be very reliable, because any violation to the reliability will cause risk on to human life. This is something similar to the software for the designed for aircraft, for example. Okay, this is very risky, you know, because it's involve human lives. It is high if it is involve financial loss, and nominal if it is okay. There is no big loss in any defect, for example, for this software. If it is defected, then it can be recovered at any time later. So the risk here is not neither low nor high. So and so on. So this is an example. Okay, so how to decide the level of reliability for the software project. And the same thing for the other. You can read in the book and you can understand what's. But also bear in mind there is this document is very old, so the information here is maybe need to be or it should be updated. I mean, because the model is quite old. I mean, uh, it still can be used for, but the regarding the attributes, you still have a problem here, because uh, for example, in the computer attribute, it says if the software is consumed like 50% or less than 50% of the execution time, like 50. But now we understand that the CPUs are very high in speed, so this actually information is not accurate here. This actually need to be changed or need to be updated to go along with the change in the technology, and the update the high update in the technology. So, and the same thing with the storage, because we have now hard drives are very high in capacity, so this actually information is not is not that true. Okay, so this is just to keep in mind. The other information can be used, for example, like the personal attributes, for example, the analysis capability, if the guy is or the, for example, for the application experience, if he's has less than 4 months of experience, then it's considered to be very low. If he is just 1 year, then it is low. 3 years, it's nominal. 6 years, it's considered to be highly high experience with the application, and so on. So this information are fine, but maybe the information related to the computer attributes are not that accurate, especially at modern time. So now what we need to do is like this is an example of a single project. So we have all the cost drivers here, and we have the rating for every metric. And for example, for reliability it's high, so this is the number. For the data is low, so this is the number, and so on. So what you need actually to calculate the multiplier. So multiplier is to multiply all these numbers together, and you get the what is called effort adjustment factor. So or what is called the multiplier, okay, the product of effort multiplier. So this number, like our number here, the multipliers. So in this cell we created a very easy formula here, because it's basically is multiplying is equal to and multiplying all the numerical attributes. So starting from I2 until this cell AK2. So starting from I2, this is I2. So we actually multiply this value by this value by this value by this value and so on until the last cost driver metric, and we get the answer here. So if the first project is the factor or the adjustment factor is 102, and the second project is the factor is 3.54 and so on. So this is actually so the last step is to get the estimated effort. So the estimated effort in our case is going to be this number multiplied by this number, and you get the answer here. So this is the formula here. Here this cell here is equal to this cell multiplied by this cell, and you get the answer here. So you have the estimated effort, and this is the actual effort which is given in the data set. So you need to compare these two numbers together. So look, this is the actual effort, and this is the estimated is higher. So this means it's been overestimated, and for this one is underestimated with a very small number gap between the estimated and the actual effort. So this is it. You need to go and compare all the values together to see where is the difference. So it's rarely to find two numbers are identical. It's very rare. I bet you may not find any single, but you can find an estimated effort very close to the actual effort, and this is still very good estimation. So this is it actually about the COCOMO model, and I hope this tutorial helped you to understand the topic. And again, if you have any questions, please do not hesitate to contact me on this email address. I'll try my best to answer your questions. So I hope you do very well in the case study, and wish you very good luck.